Meeting is being recorded.
Hello, friends. Welcome to the next session. This is the second session on the demo. If you have not attended my previous session, we did a small demo on how to use generative AI and create a small application using generative AI. Today, it will be a whiteboard or a blue board kind of a session. Most of my sessions, we will use this kind of a blue board kind of a session where I'll be walking you through an example. We will be doing an extempore way of learning. And then if you have any questions, please put them in the chat window. I'll be answering them. So today's topic would be end-to-end end-to-end AI life cycle. So my handwriting is not that great, but never mind, you'll get used to it. So, so today's topic would be an interesting one where this will cover the end-to-end AI lifecycle, and specifically we'll see uh, who who can enter AI and from which door or pathway they can enter. So at the end of the session, you should get the clarity about, if at all you are a front-end developer, how do we enter the space of AI? What is the easiest path in which you can enter? If you are a mainframe developer, if you are a QA, if you are a project manager. So different roles have different entry points. And after today's session, you should get some clarity on what is the pathway in which you have to enter. So without any further ado, let me start the session. So I want to take you guys, I want to take a take a time machine or something, and then I want to take you guys 20 years ago, right? So imagine we are in the year 2005, 2006, early 2000s, and I want to create a use case scenario. Imagine there is a bank. So there is a bank. Let let me call this as ABC Bank. And the bank is doing regular transactions. So what are the regular transactions in the bank? There will be a teller or a cashier, and the teller or cashier will be doing deposits, withdrawn. People will go to the bank, they will deposit money, withdraw money. This was the earlier days of internet. Uh, Banks are still not yet adopted internet, but they're doing the regular banking transactions. People used to go to the bank and withdraw money or deposit money, open a fixed deposit, things like that. So when such kind of transactions happen, the transactions get logged into something called as ODS. We call them as operational data stores. Now, these are nothing but the operational stores in which all the operational transactions are logged. Now, what are operational transactions? You withdraw money, that is a transaction. You deposit a money, open a fixed deposit, you apply for a loan. All those things get logged into the ODS, operational data stores. Now, what are these ODS? They are the typical RDBMS, RDBMS databases. It can be your Oracles, PostgreSQL, MySQL, or any type of these SQL databases which are hosting your data. The data talks about what happened on that day, who withdrew money, who deposited money on an average day, how much was an average withdrawal, average deposit, which locations have surplus of money, which locations there are a lot of withdrawals happening. So imagine if the CEO of the bank wanted to get this kind of a report. He wanted to understand like what is the average balance of a location, which locations are withdrawing more money, which locations are applying for a lot of loans, which locations there is a lot of saving happening. Right? Some people will be getting into the saving mode. There are a lot of saving happening, so there is a surplus of money in the bank. Some other locations, there's a lot of requests for loans. There's a lot of withdrawal happening. So if a CEO wanted to get such kind of a report, based on that, they can take some business decisions. They will employ a data analyst. So back in those days, data analyst, what the data analyst will do is they will run SQL queries. They will run SQL queries on the ODS to create the reports. So the SQL queries will basically query the tables. They can create reports. They can create daily reports, weekly reports, and those reports can be scheduled so that every day they run, and there is a report which is sent to the executives. Now, what's happening is while the transactions are happening during the day, at the same time, the SQL queries were also running. So there's active transactions happening. People were withdrawing money, depositing money. At the same time, there's also the data analyst who is working throughout the day, and he or she is working on the SQL queries, dumping these queries. So because of which there is a slowness on the tables. The databases tables were becoming slow. And during that time, then the project managers decided that let us not run the queries during the day, but we will run during off business hours because there is some clogging happening. People decided that what are the business hours? The business hours from 9 o'clock to 5 o'clock. Imagine the bank runs from 9 to 5, generally runs up till 3 o'clock, but after that, there are some closing works. But just imagine the business works from 9 o'clock to 5 o'clock. Then the jobs, the SQL queries used to run after the business hours. So the concept of nightly jobs came into picture. The concept of nightly jobs came to picture, and these nightly jobs are nothing but they are the ones which are running during the off business hours, the same queries, same jobs, which will create the reports. But instead of running during the business hours of the bank, they used to run in the late hours, maybe 9 o'clock in the night, 12 o'clock in the night, and so on. Even these nightly jobs run even today. Now, there are systems which are created, these nightly jobs run today, typically during the off business hours, and these jobs will create reports for the next day. But the primary reason was to put this nightly jobs is to create a lower load on the system. And then during the business hours, there is no overhead. The jobs used to run at a different time. So that used to work perfectly. But after some time, what happened is there are two phenomenon which happened. One is the adoption of internet. Internet, that was one. And then second one is geo expansion. So what happened is because of the adoption of internet and geographical expansion, During that time, two things happened. People were quickly adopting to internet. There were websites getting created. There were mobile applications which are getting created. So the company, a typical brick and mortar company, it could be a bank or a retail company or anything, they were coming online. What did it made? So the bank is now online. It is 24 cross 7. There is a website, abcbank.com. So people can log into abcbank.com, can deposit money, can withdraw money, can transfer money, do all that stuff. Now, because of that, what happened is this 9 to 5 thing, the nightly jobs did not work because there was no such lean period, right? So lean period is nothing but this is the time in which I can run my job because the load is minimal. Such kind of lean period was not there. First reason was internet was adopted. And the second was geographical expansion. That means that a company which is in one geography opened their branches in other geographies. Suppose a bank in US, it opened the branches in Singapore, Dubai, and India, UK. So likewise, it opened the branches across the world. Now, because of which, again, during the US night time, it will be day for some other country. Like Singapore is day, US is night. So there was no such lean period because of these two phenomenons, adoption of internet and expansion of geographical locations. There was no such time that I can say that I can run my nightly job. Understood? You will understand why I'm talking about this, but I'm trying to bring the history and then eventually how the data changed, the analysis changed, and the way we have got to the current state. So back in those days, the nightly jobs can't run on ODSS, and that's the reason there was a backup system which was created, which was data warehousing. And that's how the data warehousing systems came into picture, DWH. You might be familiar about data warehouses. There was a popular process called as ETL, extract, transform, and load. Anybody having a data warehouse background, please put a yes on the chat window. You might have, you might be familiar with ETLs, right? So the ETLs came into picture, which is for extracting the data from the source systems, doing some kind of transformations, and then pushing the data into the warehousing systems. Now, the source systems are your tables, the operational tables, and the warehousing systems are kind of similar, looks similar. Sometimes they might be aggregations, they might be simplifications of the actual tables. Um, so that's where the transformation comes into play. Extract the data from the primary table, do some transformation, and then load it into the warehousing table. It is called as extract, transform, and load, the ETL process. Two things, uh, two things were beneficial because of data warehouses. The first thing is quite obvious that it is decoupling the source tables to the warehousing tables. That's the important one because now instead of running the jobs on ODSS, the jobs used to run on warehousing tables. Now I can run the job at any time. You're not worried about internet, geographical expansion, 9 to 5 bank thing, and so on. So typically the jobs used to run on warehousing tables and then they used to get discontinued on the, oh, sorry, not this one. Just a second, not this one. They used to get discontinued on the ODS table. So no longer ODS queries directly running on the warehousing queries. So that is to a typical step. The second thing which actually changed were the warehousing tables were also storing historical data. Historical data means you could store last year data, 5 years back data, and so on. Now, when you have this historical data, you could compare what happened last year with respect to the current month, right? So you could do this comparative analysis. So you could do that comparative analysis and create such kind of a reports like how was the sales last year when compared to this year. So you could do that kind of quarter to quarter comparison, year on year comparison, and all that stuff. That was possible with warehousing systems. Typically, the ODSs will have current information. They were not tracking the older data, but warehousing, when it came into play, they can also track historical data. So those were the advantages. Warehousing systems, even till today, we have a lot of warehousing systems. Um, I'm sorry, there was some annotation. Can we, just a second. Let me, yeah, let me disable annotations from others. Um, So what I was talking is that what I was saying was data warehouse systems were very popular. They used to discontinue the uh, connection to the ODS systems. They decouple that and then also provide historical data. And they were very popular. And even today, we do have data warehousing systems. Now, one thing which the warehousing systems did not have was the they are primarily structured in nature. They have rows and columns, table kind of a structure, and so on. But slowly, around early 2012, 2014 time frame, what happened is the unstructured data also came into play, where people were started storing unstructured data in terms of textual data, image data, video data, and so on. So a small switch came into play where people were storing into something called as data lakes. Data lakes started created because data warehousing systems were primarily storing structured data, but now there was a requirement to store unstructured data in terms of textual data, image data, video data, and so on. So things like big data came into picture where Hadoop was one of the primary methodologies in storing unstructured data, structured as well as unstructured data. And then thanks to cloud computing, we do have AWS, Azure, and GCP, because of which we were able to create managed Hadoop instances rather than having Hadoop run on on-prem servers. So you have to create a server, you have to install the Hadoop version and maintain it and all that stuff. People were using the cloud managed services, and this entire thing used to be called as big data, right? So the big data came into play where instead of storing both structured information, we were also storing unstructured data. So what is unstructured data? You are able to store videos. I can store a video information. I can store what else? I can store images. Images means you draw two mountains and sun. I'm not sure what you used to draw when you were kids, but I used to draw the same picture. Two mountains, one sun, and few birds. You could store images. What else you could store? You can store textual data. You can store log data. What else? You can store some sensor information. So what's happening was IoT data, sensor data, things like that. So what happening was the data which was getting stored was no longer in a structured format. We were now able to store images, videos, text data, logs data, then sensor data coming from different sources, which is structured, semi-structured, and unstructured. And that created a good amount of jobs. Even today, we do have a lot of jobs in this spectrum where it involves data ingestion, data transformation, and data storage processing. And this spectrum is called as data engineering. It's called as data engineering. People who do this work are called as data engineers. So this is one doorway to AI. So this doorway, I want everyone to understand this doorway. That's the reason we have took a little detour on history, but this is quite important because this doorway is one of the prominent doorway for entering into the AI space. So data engineering is quite essential because we need to maintain data, we need to process data, we need to transform data, local information, and so on. Now, because a lot of things have matured, we now have to maintain data in terms of knowledge bases. We have to maintain in terms of embeddings. We have to maintain in terms of prompts, libraries, and then vector stores and so on. So all those things have changed a little bit paths, but it requires us to do that maintenance, and that will be done by data engineering team. So far, so good. Are you guys following so far? If you have any questions, please put them in the chat window. I will be able to answer as and when they are relevant. All right. I hope you guys are following. If you're following, say yes. Can I get a yes, please? Yes, following. All right. So, so we took the detour. We went back 20 years and then understood how things evolved. And now we are in the state where once the raw data is available in our stores, then I can do a lot of analysis. The first steps is doing something called as data visualization. No, does all this fall under AI space? Yes, it falls. We will see, understand how the spectrum has changed over time. The data visualization is the first important step in which you will explore the raw data. The raw data is available in the data stores, the data lakes, and then now you run something like Tableau. You can run something like Click View. You can run Python-based code 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 bases for creating your reports and so on. So all this work will be done by data visualization engineer. Data visualization engineer. This is another role where it's very prominent. People will come from this door as well. But these are the people, these are the group of people who are now connecting to this raw data, connecting, creating graphs, charts, reports, dashboards, and show the information. So that's one important work, prominent work, where we call as BADAs, uh, business analyst and data analyst. BADAs we call. They are the ones who are visualizing the data, creating reports, doing some transformations, loading the data, and all that stuff. That is this work. There are other set of data engineers typically doing transformations that's called as feature engineering. So it's called as feature engineering, which helps into transforming the current features, current data into usable format. We will create something called as features, and the features are the ones which are usable and can be fed into your core systems. In the classical machine learning space, we used to create features, and the feature engineering was a very prominent step where we do data transformation. We will use big data systems, Spark, and other things where we do the feature transformation. We can join tables, do all that stuff, and then features are created. Now, what are features? Features are nothing but they are abstractions of your actual data. Imagine you are in a bank, you are every day spending money. Imagine you have a credit card, you spend money. In the morning, you do some transactions. Afternoon you do some transactions, and in the evening, you do some more transactions. Now, if I want to run any AI models, you don't need individual transactions. Are you getting? Imagine in the morning you purchase coffee, then took your breakfast, you filled fuel in your bike, then in the afternoon you did lunch, evening you went for a movie. So imagine you have all these individual transactions. When we are analyzing the data, we don't need all that individual transactions. You might need an aggregated spend. How much Sitaram spent on this day, or maybe how much Sitaram spent for this month, an average spend. So for that, you need to run a job which basically aggregates by user, by transaction, by location, and things like that, and then creates an output which is called as a feature. Understood? The features are the ones which are being used in the AI models. They are not like raw data. You will transform the data so that it is in a much more meaningful manner. It is much more condensed manner so that that information can be used by your models. Now, we are also required to do some kind of cleaning for data. For example, nowadays we are having raw data in terms of text, in terms of images. We have something called as vectors created, which will be pushed as embeddings into vector databases. For all of them, we need to use feature engineering so that it can condense all that information and put it in a right format. The central piece is where we do a lot of processing. This is called as modeling. So spend like a 30 minutes now, and we reach the central piece, which is the modeling. Now, modeling is linked between the visualization, the feature engineering, and other stuff. Now, what does the modeling does? This is the central piece of AI where you can create classical models. Cla I can call as classical machine learning, where we have supervised machine learning, unsupervised machine learning, and all that stuff. We have generative AI, and nowadays we are also having agentic AI. With agentic AI, you can create AI agents, you can create automations, transformations, and all that stuff. A lot of things is possible. But this is the central important piece, which will help us to create AI models. AI models can be classical models, the traditional machine learning models, or they can be generative models or agentic models. Or we can create agents with that as well. Many a times, many people focus on this specific section. A lot of courses, lot of materials focus on this section. Even we also will focus, half of the course is mostly on this part. But one thing for us to understand is there is a lot of periphery also, and this is not just the entire thing. This is just a piece. This is a small piece of the Lego block. A lot of Lego blocks. This is a small piece of the Lego block, much important piece, but this is one piece. So people who are working here, this is the job roles we are very essential, right? So people who work in the classical machine learning space, they are called as data scientists. Roles are data scientist. Now this is one job role. People who are working in the classical machine learning space, that is the data scientist. Likewise, the people who are working in the generative AI and agentic AI space, they are called as AI engineers. The job role is AI engineers. Two different job roles, two different requirements. Now, what they do is they create these AI models. But there is very, very essential thing after this, which is like what we call as deployments. Now, how do I deploy these models into production is a very essential piece, which we call as deployments. Now, deployments happen in two methodologies. So first one is a batch deployment, and the second one is online deployment. Now, what is a deployment? Deployment means, of course, I got this model. You have created a model, but this model has to be deployed into production, right? Many times people just focus on the models. You create a model, you get some accuracy, you get some output, that's done. But that's not really done because you don't know how to deploy that model into production. There are specific processes in which you deploy these models into production. What are the techniques in which you deploy the models into production? What toolings you need to use? How do you create Docker containers? How do you use some of the toolings to deploy those models into production is quite essential. Two methodologies are there. There is batch and there is online. What does batch looks like? Batch means you schedule it as a job. Maybe you push it into some kind of a cloud, say AWS cloud. You run this model on the cloud, and there is a job. There is a job which runs every day, say 9 p.m. And this job basically takes the records, uh, uses the model, does the prediction, and creates new records. So there is a upstream job and a downstream job. Say like every day 9 p.m. there is this job running, which is taking the suppose I take a bank example. In this bank example, we want to predict the loan eligibility of the users. So every day we will collect whoever has applied the loan for that day. We will collect their records, and we will use this AI model to predict the loan eligibility. And the model will predict for every customer. Imagine there are 100 customers who applied loan on a particular day. We will run the job in the night, and the model will predict for every customer what is the eligibility. And just imagine that out of 100 people, there are 82 people who got loan approved. Then the model will create a new file with approved list of users. And there can be a downstream job which will be sending an email to all the users saying, congratulations, Sitaram, your loan is approved and you're approved for so and so amount, right? So that is called as a batch processing. Are we getting? So batch processing is like you are scheduled jobs are there, your model is there, and then your model is doing predictions and then giving the results in a batch mode. Similarly, the online is much easier because now this is it's creating a API. It creates a API, a REST API, and the REST API will be triggered from, say, like a mobile or a web application. So there is a web portal, it is triggering the API. The web portal is like abcbank.com. So the abcbank.com, you log into the bank, you give your information and then say apply. So once you click apply, that will call the API. API will be fed with the model and the transaction is triggered in the real time. So this is the real time mode where instantaneously the model is doing the prediction, but it is one at a time, right? So you log into the website, you fill in all the details and then submit. And once I submit, it goes, the model gets triggered and it gets response immediately. That's a online mode or a REST mode. In a batch mode is more like a batch processing, typically happens once in a day or maybe happening once in a month. So likewise, you will trigger it. These are called as deployment. So here it is very essential for doing these deployments. In the classical machine learning space, you can call this as ML ops. In our generative AI space, we call them as LLM ops. Agents in agentic thing, it is called as agent ops. The names have changed over time, but the purpose is same, like how do you deploy these models into production? And the people who are working in this space, they are called as ML engineers, right? So the purpose of ML engineers or LLM engineers is how do I deploy the models into production? So they are the ones who are having the information, knowledge about DevOps. They are the combination of software engineers plus DevOps engineers. And they know like how do you deploy the models, scale the models, or do all that traditional production deployment techniques. Got it? ML engineers also does one more thing, which is a connected thing. It is called as monitoring. Monitoring is where you talk about explainability and then fairness. Explainability and fairness. There are multiple things. It's very, very essential for us to understand. Like monitoring is after the model is deployed into production. Suppose say January 2026, you deployed the model. Now we are in April 2026. What is the condition of this model which is deployed in January? Is the model good? Is it working properly? Is it any deviance? There is any drift? Is it the predictions are accurate, or is it decaying? All these things are very essential because if you don't keep track of that, it is doing predictions, it is doing some suggestions, it is doing some recommendations, which is going to hurt your customers. We need to make sure that the model which is already deployed into production is as per the given rules and regulations. There are certain kind of metrics you need to track. We will understand about all those metrics, but there are some metrics with respect to classical machine learning. There are metrics with respect to LLM monitoring, drift detections, hallucinations, proximity, and different kinds of trackings we need to do to ensure that the models are running properly in production. One more important thing, we call them as AI protocols. Two things, which is the governance and quality. So we need AI quality. This is where the AI quality engineers, the SDETs, call as machine learning testers, AI testers, the QA people. This is one very essential role. Now, because in my company, we're trying to identify how do we create agent testing, right? Now, people are just thinking about creating agents. I will use Anthropic Claude code, and then I'll create agent and I'll do something. But of course, you could create an agent, but how do we test the agent? What are the metrics in which you test the agent? Because this is not a software component. There is a mechanism in which you need to test the agent. There is a mechanism in which we test the LLMs. So those frameworks are quite essential, and those job roles are also very, very essential. Like, how do we test the models? How do we test the agents? How do we test the LLMs? So that falls under the AI quality, which comes under AI protocols. And then the governance talks about the primary roles of business analysts, product owners, project managers. So these roles, and they take care about the project overall governance. When I talk about governance, that means that what is the business case? What is the workflow? Where do we need to embed AI? Right? What is the ROI we are going to predict from embedding the AI in a specific use case or workflow and so on. So there is a proper business case which need to be created. There is the expertise which will come up from a project management perspective, product owner's perspective, business analyst perspective, and they will help us to drive the ROI. So if you ask a technical person, a developer, they will try to embed AI in every field. And we will try to search for ROI from the implementations. You will end up spending a lot of money, you'll end up spending a lot of time, effort, and energy, and you will not get any ROI. So it is very essential from a business standpoint that we need to identify the journeys, we need to identify the workflows where the AI can be embedded effectively, and the work will be done by the project managers, delivery managers, product owners, business analysts, and understanding AI knowledge and subject knowledge both helps us to do AI governance. Governance talks about your audit processing, ROI analysis, efficient use of AI, and all that stuff comes under the governance piece. So we spent 45 minutes and I was able to completely draw the end-to-end life cycle, starting from the ingestion till the governance piece. And as a process, we looked at couple of doors, right? There is data engineering, there is data visualization, data scientist, AI engineer, business folks like product owners, product managers, SDETs, ML engineers. These are different roles. everyone will have their own way to enter the space of AI. So you can think like the central space is where you have core programming expertise, that this is where you need to know a lot of programming or coding or knowledge. But there are multiple pieces where you do not need programming knowledge, but having a knowledge of AI will help immensely. Suppose you are a project manager, understanding this space, understanding what tools to use, how to use them, and then having the knowledge of business ROI and projecting that is much more essential. If somebody from a QA background, I will recommend them to get into the AI testing space because that is very close to heart. They will be able to comfortably do it. They know how to test LLMs, they know how to test models, they know how to test agents. And then eventually they can either become a machine learning engineer or an AI engineer. Somebody who is coming from a DevOps background, I will recommend them to start with ML engineering because they know the concepts of DevOps, they know how to productionize the applications, they know the CI/CD pipelines, Jenkins, Dockers, all those things they are familiar with. So it will be very easy for them to adopt. Somebody who is new to the market, fresher, they are familiar with programming, they want to enter. The best space is AI engineer. They can learn about generative AI, agentic AI, and get into the AI engineer space. This is the space for somebody who is also doing maybe front-end engineering. So they are building websites, they are familiar with Node.js, they are familiar with React, Angular. So for them, the role is also AI engineer. Somebody who is heavy in Python, they are familiar with Python, doing programming and so on. They can get into data scientist roles, junior data scientists, senior data scientists, who need to create models, deploy models, execute the models, experiment with the models. All that stuff happens by the data scientist. We also have a path for data visualization engineers, and they can get into either data scientist or AI engineers. For data engineering folks who are doing data warehousing, ETL processing, they also can get into AI engineer, but the path is through the data engineering space. So depending upon, there is no one fit rule for anyone, right? So there is no, this is the best role, this is the one you have to do. There is no such kind of a thing. It depends. The reason I'm talking about these doors is it is very essential for us to know the pathway from where it is very easy to get into the space. Like everybody now jumps into becoming an AI engineer or a data scientist, but it might not suit them directly, or you might not get a role directly. Are you getting? So imagine a QA person directly jumping into AI engineer, they might not get a direct role. Best methodology is becoming a QA person and then getting into it. For Java developers or any other developers, the space is AI engineer or data scientist. Right? That is a recommended role for Java developers. They can either become an AI engineer or a data scientist. These are the two things because they are already program heavy, right? They are already familiar with programming. They are already familiar with software engineering and things like that. It becomes very easy to embed systems. Worldwide, the top enterprise software is Java. It is not Python. It is Java. Java, Spring Boot. It is the most widely used one. So if at all I want to embed AI into these systems, the best use is they knowing the know-hows of AI. If a Java engineer knows the know-hows of AI, it is like a deadly combination, right? Because you see any of the enterprise applications, they are pretty much predominantly over the years. Now, we also have .NET. I don't want to say .NET is less, but predominantly Java is where there are a lot of work happening, right? So somebody who is having the Java background, who also now know AI, can know how to embed AI into that will be a deadly combination. All right, so now I will break. It's 50 minutes, so I was non-stop talking. I just want to check if you guys have any questions so that I can answer them. If you have any questions, please put them in the chat window. All right, no questions. Interesting. Is it clear? Did we understand the entire flow? Is it? Can I get some feedback? Are you guys understanding? Right? Because this is very essential so that it helps us to get into the space, right? We know what to learn, we know clearly what to learn, then it becomes very essential for us to get into that space. Okay. So there are a few questions. Is it possible for an automation engineer knowledge in Python to become an AI engineer? Yes, if you have a knowledge in Python, the easiest path is AI engineer. The easiest path is AI engineer. If you already have a knowledge in Python, that is, you can become AI engineer. So anyone from testing background, as I said, you become the AI tester first. Don't jump into machine learning engineer or AI engineer immediately. Please focus on the AI roles. And believe me, 4 years back, I created a role called as ML tester. Back in those days, there was no ML tester. ML tester means classical machine learning testing, right? We need to test that applications also. So we created roles called as ML testers. Then eventually the roles came into play. Now we are creating roles of agentic testers. We need somebody to test agents also, correct? Now that roles are going to come. So our focus should be we know some things like for a couple of years, imagine I'm in the testing space. For a couple of years, I have strong knowledge on automation testing. I have strong knowledge on test frameworks and so on. Then it is very easy for me to complement that and apply in AI to test the AI applications. And that is a very needed role. There are also people who require that kind of a rolling. So if there is a possibility to move within the company, that will be the first best option, that you get into an AI project, helping them to test, and then eventually getting into the AI engineering space. This is the place, right? So that should be the route. So there is a question, will this course be a focused on modeling, data scientist and AI engineer? Primarily, yes, this is the one, but we will also cover the deployments and cloud and other things as well. So if I go back to my previous slide, if you see this is the structure of the course, we are here. We are getting into the AI introduction to ML. We will spend the next few sessions on understanding machine learning, generative AI, agentic AI, combinations of that. What is the difference between AI, ML, DI, DS, ASBS, all that stuff. We will do it in the next session. But the couple of sessions, we will talk about the basics. And then we will get into the Python for AI. Then we will spend good time on classical machine learning. Then we'll spend a very, very good time in generative AI and agentic AI. So that's about it. And that's how the flow will be. So will this course cover how to test AI agents? Yes, I'm going to cover that because that's the work I'm also doing in my company. I'm trying to create how do we do AI agentic testing. We have evaluation metrics. So I'll be talking about how do we evaluate agents, how do we test agents, How do we optimize the ROI, cost efficiency, internal monitoring, uh, and all that stuff we will learn. Because the biggest challenge currently we are facing is I can open up the agent for the developers, but I will end up spending so much money, right? You'll spend $100,000, and what did we get out of that? Nothing, right? So you need to create very solid testing practices there to see like how that works. All right. So one question, you have no coding knowledge. Do you recommend the course for me? To be really frank, you need to have at least an understanding of programming. Any programming is okay. It doesn't need to know Python programming, but if you know any other programming, it is good enough. Or else, I would recommend you to learn programming. You could do it while doing the course also, but you need to spend little extra effort, time for learning that, right? How can a DevOps cloud engineer leverage this course? It is on the LLM ops side. So as you see, machine learning engineer, that is the path you need to get into ML ops or LLM ops. This is the role, right? This is the space to get entry into. A lot of roles are there. There's huge demand for ML engineers or LLM engineers where you need to help in deployments of the jobs. How do you deploy agents? How do you deploy underlying systems? How do you make it scalable? And so on is quite essential. So this is the space we will focus on. So after completing this course, how many years of experience we can maximum enter into the market? I will be frank. If it is like a fresher, you could enter with a 2 year experience. But my students will be mix of people. They will be having different experience level. They are fresher into the market. They are already working as 5 year, 10 year experience, 15 years experience also. So if they are already experienced, I will encourage them to leverage their experience and get an entry into. For a fresher, you could enter into like a 2 year experience professional. Right? So the question is like, what are the topics related to project managers and business owners? So there are topics with respect to ROI analysis, governance, model protocols, how do we create use cases, and so on. Those are the generic topics, but the course is not focused on specifically them. The course is focused on making them AI engineers. So they need to know like what are the tools required. If at all a project manager is there, now they need to know how to leverage AI, what existing tools are there, how is their infrastructure, which kind of applications they can use, how the cloud space is evolving, what existing toolings are there so that they can recommend the tools for building their applications. So for somebody in the project management space or delivery space, they will get equipped with all this knowledge. Understood? So what role should I choose as a fresher? The best role is AI engineer. This role, AI engineer role. All right. There is some other questions. So if somebody starting fresh, getting into data engineer role and then to AI engineer role. This pathway is also very solid. Somebody is doing data engineering. It's a sure short pathway to get into AI data science. Data engineering is core, guys, right? So this AI space is evolving quite fast, rapidly because the change of LLMs and things like that. But data engineering is rock solid because we need to create the data, transform the data, push the data, prepare the data. For all that, we need data engineering, right? How is the AI engineer different from data scientist? Data scientist is typical using classical machine learning. We will learn both of them, but this is more classical machine learning. This is more using LLMs, agents, generative AI, agentic AI, so on. You can think AI engineer is latest, this is old school, but both are important. Understood? Can you weight the course according to the role? Mostly focus on AI engineer. First rank is AI engineer, second rank is data scientist, third rank is machine learning engineer, fourth rank is data engineer, fifth rank is data visualization, sixth rank is SDET, seventh rank is BA. Did you get all the ranks? But we'll cover most of them. But from a focus standpoint, AI engineer first, then to data science. Current market, a lot of roles are in the AI engineer space. All right. Wonderful. I think you're bombarded with a lot of information today. I think you'll get a good sleep. If you are in the US, you should get a good sleep today or no sleep, depending upon how you are thinking about the space. But I hope that you spend 1 hour, quality 1 hour. We are just on my clock, it is 8:04 a.m. So we spend 1 hour, and I hope that this 1 hour was um, worth enough spending and understanding the different spaces, which space is essential for us. It's very essential that we get into the right space so that it helps us to have a good pathway, at least a couple of years pathway for us to stay. But one thing which I would like to end the session is, irrespective of which role you are trying to take, please be mindful that AI is here to stay, and it is having a very rock solid foundation, and it's very essential for us to get equipped with the tooling. It doesn't matter you do this course or not, it doesn't matter. But please take this advice, small advice, that make sure that you understand how the space is evolving, how the space can change the way in which you are operating. You might be a mainframe developer. You might be Oracle DBA. You might be QA tester. You might be any job role, maybe SAP, CRM, or anything. Every field we are seeing that there is the involvement of AI. Somebody who's in the say like mainframe background, people do not know and have an understanding of COBOL. People do not know understanding of JCL and background of that and so on. But somebody who already knows COBOL, if they have the knowledge of AI, they are the first entrants in the space of mainframe to modernize that. So each and every one of us should look in that lens. It's not going to take away our jobs. It's not going to fire people. It's not going to do anything. Of course, such kind of things will happen, but we will not be those people. I would like to end the session with that positive note that we will not be those people who are getting into that, state of, that ambiguity. So we'll be on the other side of the equation. So I want everyone to think about this thing, that what is the current role they are doing, how they are doing, and the future is going to change very, very rapidly. And it is not an option anymore that, that I will have some information and so on, because now the space is changing at a very rapid pace. It is very essential for us to understand the space. So I'll leave with that, with a positive note that you are going to be on the other side of the equation. So we will not be having any problems. All right. Thank you. If you have any further questions, keep it with you because I'm going to close the session. We will come back tomorrow and discuss more things. Till then, take care. Have a good night. And I'll talk to you tomorrow, same time. Sessions is already started. When are the sessions going to start? We're going to ask questions. There's no specific class for question answers. I'll spend like 10-15 minutes, um, like where we get the questions sorted out. You can either ask in the chat or you can unmute and ask question. But I would recommend chat because it is very easy for answering. And most of the questions I'll answer. It is not like I'll leave out any questions. If I unknowingly, if I left any question unanswered, please let me know. But most of the questions I will answer. All right. First few sessions, there will be few doubts, right? But as we go deeper into the course, as you know, my way of dealing with the course and so on, you will blend slowly. Okay, the questions get blended. So please bear with me. Couple of sessions, please go through it. You understand the way I teach, and then if you further have questions, no problem. We will spend one session specifically answering the questions. All right. So thank you very much and have a good night. I'll talk to you tomorrow, same time. Take care. Bye bye.